Hello friends, I am excited to share that I am successfully completed LSB image steganography by using C programming language. Today I am going to show you my project on LSB image steganography. Before going to the LSB image steganography, what is steganography? Steganography means hiding some of the information, like hiding some of the text or audio or video information in some of the text or audio or video files. Then why the steganography is important and how the steganography is implemented and where the steganography is mainly used. Okay. Before going to all these things, why the steganography is important? To hide some of the secret credentials. Like I will take one example. As we all are very familiar with PhonePe, right? In PhonePe, we are keeping some of the secret pins. Why we are keeping that secret pins? For the sake of security purpose, right? So any other another persons can't access our account directly. For that purpose, we are using that secret pin, right? And to detect some of the data forgeries or to pass some of the messages to another persons. There are we are using this technographies. Okay. How in which fields mainly this technography is used? Okay, firstly in military applications and in in online elections and in internet banking and in medical imaging. In that all fields, we are using this steganography models method. Okay. How this steganography is implemented? There are so many ways by using physically, by using print and prints, by using puzzles, or by using digital. We are going with digital because we are encoding some of the secret data in the image. So this digital method is very preferable. So we are going with digital image steganography. Okay, let's come to our project LSB image steganography. What is why the LSB why the name is given as LSB image steganography only? I will explain. We are hiding some of the secret data in the LSB bits of the LSB bits or LSB pixels of the images. Then what is pixel? Pixel means smallest unit in the image. Okay, how the pixel will be formed by using the color models. Like if the color model is RGB color model means the pixel is formed by using 3 bytes. If the CMYK model means the pixel will form by using 4 bytes of information. Okay. In our project, we are mainly using two operations. One is encoding, another one is decoding. What is mean by encoding? Encoding means hiding some of the informations to in the image. Then what is decoding? Whatever the hidden image is there, na, hidden data is there, na, we are extracting the data from the image. That is decoding. Okay. In encoding, we are mainly encoding five things. One is magic string, another one is secret file extension size, secret file extension, and secret file size, and the secret file data. This mainly five things are we are encoding. Okay, then what is magic string? Magic string is the one it is acting like a key. Okay, to indicate that the data is hidden, hidden data is exist or not. For the whenever we are decoding, we can't know na, how whether the data is encoded or not, whether the data is exist in the image or not. For the sake we are using this magic strings. Okay, secret file extension. We why this secret file extension means we are keeping some of the data in the files, right? That file is that should be an image file, dot txt file, that should be an .py file. So if you are encoding this extension means for the decoding it will be very useful. For that we are encoding the secret file extension size and extension also, and how much data we need to encode. For that we are the size is required. Now for that purpose we are encoding the secret file size also. Okay, I will show. This is my secret text. Okay, before going to this one, how the data is secret data is encoded in the images. Suppose if you are having let's take an example of magic string. If you are having two characters of magic string, for each bit of secret data, we will take 1 byte of information from the image. If you want to encode 2 bytes of information means we require we require 16 bytes of image data to encode one character means 8 bits, right? For one bit we required 1 byte, for 8 bits we require 8 bytes. So if you want to encode 2 bytes means 16 bytes of image will be required. Okay, for encoding purpose, this is input. For encoding the secret.txt will act like input, and the beautiful.bmp. Why we are selecting the bmp file only means this is unstructured and we can hide some of the large amount of data, so we are going with beautiful.bmp files. Okay, uh, this is secret.txt. Okay, one txt file, and another one bmp file is acting like input here, and we are passing this file to the encoding. So for each bit of data is encoded in the last image byte. Okay, we are passing these to the input as encoding. So some of the operations we will do. After that operation, uh, we will generate one output file, that is some of the image files. Okay, and in this image file the secret data is encoded with this beautiful.bmp files. And one of the very important why we are using lsb image technography only means we are encoding in the least significant bits. So whatever the image is there now, this color and this color should be same. We will get exactly the same color, but the thing is we are encoding some of the secret data is here. This is full of encoding. Okay, and in decoding this output generated file is there now, it will act like a input to the decoding part. After that we will decode some of the whatever the encoded part is there now, we will decode that part. So after decoding we will get the secret data. This is the flow of our project. Okay, first we will pass two input files, and from that we will generate one output file, that is one image file. And that image file color is should be the same as the input file. If the color is same and the same data is encoded means okay, our data is successfully encoded. And that whatever the encoded image is there now, we are passing that image as input to the decoding. So that after extracting the input output file, we will generate the secret data. This is the flow of our project. Okay, this is one of the .bmp file. Okay, let's go to our project demo part. Okay, this is our project demo part. In this main.c, we are only uh, we are only having two operations. We using two operations. So we are calling only two functions. First, do encoding and do decoding. In do, if if the all the passed arguments are correct means we will go to the do encoding part. If the all the arguments are after that, if we are complete successfully, all the arguments are successfully done means we are passing messages encoding is successfully completed. After that, for decoding purpose also we are using same thing. Okay, and in encode.c, the all the encoding operations and all the logic of the encoding operations is included here only. And in encode.h, all the function declarations of the encoding part, there are mainly 10 to 15 functions are there. Those all functions declaration is present in the encode.c only. Okay, this is our input image. This is our input image. Okay, this is our input.txt data. Okay, I will pass okay, I will show. Okay, okay, this is executable file. We are passing for this for encoding minor we are passing as -e. This is input file. input image file. This is input secret data where the whatever the data is present in this file only, and we are passing the output file, and this output file is optional. If you are not given the output file means the system will automatically, we are implemented that the output file should be automatically generated. Okay, I will enter. Okay, encoding is completed successfully. Okay, here the encoding is completed successfully, the image is generated, and in this image we are having secret data in the image. See, this image and the input image is similar only, right? Okay, we will decode. Okay, this is hyphen D is for decoding, for the decoding purpose, and whatever the uh, output we are generated here output is generated of the encoding image, right? We are giving to the decoding. Okay, and this is optional. If you given me guru means that secret whatever the extension we are encoded na, that encoded extension is automatically concat with this file. Okay, decoding is successfully completed. Okay, this is guru.txt. Okay, guru brother successfully completed the steganography. Okay, this is my project demonstration part, and I uploaded my uh, uh, project code and full project code in the GitHub repository, and uh, I mentioned that GitHub repository in description also, so you can easily access my GitHub account also. Thank you, thank you.